Hi, everybody. I'm Hunter Hawk, our security solutions architect here at Smallstep. I'm joined with my counterparts, Jesse and Ryan over at Jamf. Not sure if you could see them in here, but they'll be popping in for Q&A at the end. Let's see. Jen, should we give it another couple minutes, or do you think we're good to kick off?
Yeah, give it another minute or two.
Sounds good. Jesse, Ryan, do you want to pop on real quick and introduce yourselves?
Sure. Hey, everyone. Good morning and afternoon, depending on where you are in the world. My name is Jesse Jesselhouse. I'm a sales engineer with Jamf. I support some of our named customers around the country and in the EMEA region. Been at Jamf for about 8 years. Good to be here. Ryan?
Yeah, I'm on the same team with Jesse, so basically the same thing. But yeah, it's really great to be here, and look forward to answering any questions that we have towards the end. But yeah, really looking forward to it.
Cool. Thank you, guys. So here in our presentation, we're going to be discussing Smallstep's inventory integration with Jamf, and specifically how we can integrate deeply with the Apple ecosystem via Jamf to achieve hardware-backed key-attested credentials anywhere you need them. For today's demo, I'm using Wi-Fi since it's relatively straightforward. You might see my other client here pop up and drop off the call as it jumps networks, but such is the way of demoing Wi-Fi. So what is Smallstep? What do we do? We are a device identity platform, the world's first and only. And what this means is that we can help businesses enforce device identity for everything. So making sure that only devices that are in inventory, in the case of our attendees here in Jamf and managed by your organization, are even capable of accessing your network and all of your most sensitive resources, whether it be PII, PCI data, GDPR, et cetera. So what's the problem that we're coming to solve here? Certificate-based authentication has been around for decades now. Chances are you're using Active Directory certificate services or some similar CA using the SCEP protocol right now for your Wi-Fi authentication or VPN, ZTNA, et cetera. The problem that we found that we're running into is that the core technology, SCEP, is an absolute dumpster fire. This is one of our slides that I pulled from our CEO's decks. I love it. But the problem we see with these more legacy technologies is that the SCEP protocol is used where an MDM pushes down a profile to a device, and that profile contains a password. And so from there, to get that certificate onto the device for authentication, it then has to use that password to request a certificate with whatever settings, whatever attributes it needs. And then from there, it gets stored on disk where it can be accessed by whatever program, application, network resource that needs it. There's a few inherent problems with that. One being we don't like password protocols because there really is no assurance whatsoever that the password wasn't stolen in transit or moved off the device and run on a different one. And then from there, assuming it was run on the device in scope, what's stopping your user from taking that certificate and key written in plain text to disk and emailing it to themselves or popping in a thumb drive and pivoting over to their gaming PC, which they would much rather work on? Or say, for example, you don't support Linux and you're trying to force your developers to work from Apple. This is a good way of forcing them to work from their Apple device instead of popping a cert, jumping on their Arch Linux box that is unmanaged. And so what we're doing is we are binding access back to the secure enclave in the device. So all devices that have been built in more or less the last 5 to 10 years have either a secure enclave or a TPM chip in them. This is a cryptographic coprocessor that is responsible for storing a key pair issued upon manufacturing of the device. It is burnt into the hardware on this chip. It is unchangeable. It is non-exportable. And really, you can only get into this data, this key material, by tearing apart your laptop, taking the TPM chip out, and then inspecting it under a scanning electron microscope, which is kind of beyond all of our threat models, I like to think. So using this technology, we partnered with Google a couple years ago to write an extension to the Acme protocol as a replacement for SCEP. And how Acme works is it can do typically domain validation or server like URL based validation to prove ownership of a domain. In this instance, we have extended the protocol to also be able to do this against an inventory of trusted TPMs or secure enclaves. Secure enclave is what's in a macOS device. So given the attestation keys, the serial numbers in a device inventory record, we can then fire off an Acme challenge from the client, natively supported by the Apple ecosystem in all of its operating systems, to then request a certificate hitting Apple's attestation authority, attest that it is this device with this serial number, with this given secure enclave, trusted by Apple. And then from that, upon proving its identity cryptographically via that challenge response from our attestation authority, from there, the certificate gets stored bound to hardware back to the secure enclave where it is non-exportable. You can't exfiltrate it out. And effectively, anywhere that you're using this credential for authentication becomes effectively unphishable, which is a claim I don't love to make, but in the case of our technology, you become literally unphishable because the second factor that you're using for all authentication flows is physically tied to the device kicking off the request. And so there's an entire threat vector here that you're just completely staving off. So that's the technology and scope here. Obviously, this is a lot of hand waving around what the implementation looks like, because at the end of the day, that's a protocol. How does this work? And so I mentioned that this is natively supported via the Apple ecosystem. They support the Acme protocol via their secure enclaves in their MChip series. Around this, the Smallstep platform leverages a few things that make this actionable in an enterprise setting. And so we can do hardware-bound issuance of credentials, but if you don't have an inventory, if you don't have certificate authorities for signing, if you don't have managed configuration on these clients, there's not much you can do with it. And so our platform builds around our open core STEP CA certificate authority technology to run it highly available, in addition to another few key focuses here. So the 4 tenets of device identity, if you saw my last webinar, are inventory, credentials, configuration, and enforcement. All 4 are required to run Acme device attestation in this corporate enterprise setting, because you need a full inventory of these are the 10,005 devices that are in Jamf and can get on Wi-Fi. It's no more, it's no less. These are the ones that can physically access Wi-Fi. And I would like to prove that cryptographically. And so that's where Jamf comes into play here. We have a native inventory sync with Jamf that goes ahead and pulls a read-only sync of all of your devices and their metadata from Jamf over to our device inventory, where from there we can centrally manage them, as well as any certificates that get assigned to them, any relevant resources that they might need access to. We can pull this inventory directly from Jamf to populate out. These are the 10,005 devices that can connect to Wi-Fi. And then from there, Jamf actually has a really tight integration with this ecosystem that I'm quite proud to work with, where just like you could push down a SCEP profile out to these devices to request a SCEP-based certificate, they also support an Acme payload, which I'll show you here in a moment as part of the demo. And so the configuration can also be accomplished via Jamf here, where you would just as you would set up a Wi-Fi configuration profile today, you would literally just remove the SCEP payload, replace it with an Acme payload, and point it at one of Smallstep's attestation authorities following a device enrollment flow from this read-only sync from Jamf. And so you're hitting the inventory and the configuration sides both via Jamf in the tooling that you're already using today. And so the benefits here are tenfold. You don't really have to worry about onboarding and enrollment flows because all of your new devices go into Jamf, get synced over to Smallstep, and then immediately have access to these resources, but with this hardware-bound credential, where you have a cryptographic proof that these connecting devices are actually coming from the hardware associated with the serial number. If there's any questions as we go through this, please feel free to pop them in the chat here, and I'll keep an eye open. And Jen, if there's any important looking ones that I missed, please feel free to interrupt me.
Sounds good.
So let's see. So as part of this demo, I'm going to show a Jamf inventory sync. And then I'm also running a Smallstep managed enterprise radius server in order to do secure Wi-Fi. So there's a few key components to the Smallstep platform that I've been hinting at here. One is the inventory component, and then we have the protected resources, where we can configure settings for which devices have access to which resources, and then configure the infrastructure required for them. So in the case of Wi-Fi, 802.1x Wi-Fi, we can configure a enterprise radius server for you, geo distributed anywhere in the world that has a GCP region effectively. So super low latency, supporting reply attributes, VLAN tagging, all, etc. Those sorts of enterprisey features. I'm doing this because it comes included, and I'm not running an external NAC. But if you're running a Aruba ClearPass or like Cisco ICE or some other radius server, that is also fine. We can just plug into an existing radius server as well. But if you're missing the core infrastructure to upgrade to enterprise Wi-Fi, it comes included as part of the product. So let me jump into the platform. What I'm going to show you here is a demo on Mac OS enrolled in Jamf. I am connecting Jamf to my Smallstep account to do this inventory sync. I've gone ahead and done that. I have also gone ahead and configured a Unify router to trust my radius server and client credentials, and then an Acme payload in Jamf to go ahead and authenticate these requests from start to finish. And so I tend to love these particular POCs because realistically, I can sit down with a prospect and nail this out in less than an hour from start to finish. For today, all intents and purposes, I don't want to run into any propagation delays or edge cases. So I have a couple things set up here. They are my Jamf inventory sync. Specifically, I wanted to have this set up ahead of time because this is my testing tenant, and I don't want to try moving MDMs around different teams. So here is my Jamf integration. We have this set up using basic authentication against Jamf. And then what that did is it pulled over an inventory. You can see I have Intune in here as well. An inventory of all of my Jamf devices in all of my macOS devices in Jamf. So here's the one I'm working out of. Outside of this, we also have a protected resource in Smallstep. So this is where we can map protected resources that you're allowed access to devices in scope. In addition here, this is where I'm managing the radius configuration, for example. But Wi-Fi is one example. It's one use case. You can use these certificates realistically anywhere that supports TLS-based authentication, whether that be Wi-Fi, VPN, and I use Wi-Fi loosely, wired Ethernet as well. We're also rolling out SSH, hardware-backed SSH certificates as part of our SSH product, and single sign-on is my personal favorite integration. We have single sign-on integrations with Entra ID, Okta, and Google Workspaces, where instead of getting Okta Verify on your phone, FastPass, or like the Authenticator app or an SMS, we can just authenticate using the Secure Enclave as your second factor. So again, never having to leave this device for multi-factor authentication. So in here on this particular Wi-Fi resource, I have this configured for my local NAS. This isn't required for enterprise radius. Once we drop proxies in a per location basis, we no longer need to check this, but since I'm using our multi-tenant environment, I'm specifying my IP. I'd like to auto join, and then it spits out these radius server details that I need to configure my radius. Well, to configure my access point. So in my case here, I'm using Unify. On my router, I have 2 SSIDs. Arbitrary network name is open using WPA2 with a password. Indomitable Human Spirit is my WPA3 enterprise network. And so to set this up with radius, all I had to do was upgrade it to WPA3 enterprise and then specify the radius profile that I wanted. And so using these settings here, or your given radius provider, I've set this up with the IP address, port, and shared secret with my Smallstep radius server. Later on down the line, when I set this up with Enterprise Relay, I can also enable RADSEC as well, which would be encrypted radius. So this is the only configuration I needed to make on my Unify router, since we're trusting Smallstep's radius. And then for my assignment policy here, I have a couple requirements. And this is where we can do mapping of protected resources to devices in scope. So here I have it set that any device in my fleet of devices that is Linux, Windows, or Mac OS, so I'm excluding Chrome OS, and is high assurance, so has done an ACME attestation against Smallstep and cryptographically proven its identity, can then access this resource and get on the Wi-Fi network. And for the lifetime here, I have 1 day, and this is going to use an ACME-based certificate flow. And so in here, this went ahead and set up an ACME endpoint for me to use. Now in Jamf, let me jump over here. So recapping real quick, we have the devices in inventory. We have the protected resource in Smallstep set up, which goes ahead and configures our signing authorities behind the scenes with the relevant provisioners, the relevant configurations on my behalf. So here it's set up an ACME endpoint. And in Jamf, now it's just a matter of configuring the profile. So I have, for my Wi-Fi demo here, a configuration profile adding a handful of resources. So number 1 is the ACME certificate. This is the important one. You'd use this in place of a SCEP certificate. You'd pass in the ACME directory URL associated with your Smallstep resource. The client identifier will be the serial number. This is imperative as ACME device attestation requires the serial number against Apple's attestation authorities. So this is the serial number. I'm using a key size of 384 with an elliptic curve key type, specifying that it is a hardware-bound key and that it's doing attestations. So from there, it's non-exportable, well, non-extractable, and I'm allowing all apps access. So this is just a given certificate, hardware-bound. And in here, I have the root CA certificate and the intermediate CA certificate for the certificates that I'm using to connect to Wi-Fi. So I'm making sure that my clients trust my root CA. And then as well, I have my root certificate for my radius server here. So this way my client knows to trust the given radius server. And then beyond that, I have an additional network payload configured here. Let me make it so you can read it. To connect to Indomitable Human Spirit, auto join using WPA3 Enterprise, EAP TLS, and then under the trust, I'm specifying that we are authenticating with the ACME certificate, but trusting the radius root. Relatively straightforward. This mimics exactly what you would see in your basically any other network configuration you probably have deployed today via Jamf. You just swap out the Acme payload instead to upgrade the security characteristics of these certificates at virtually no added work for you. So right now I don't have the scope to any devices. In a moment, I'm going to share my screen on my client enrolled in Jamf, and then add it as a target here in the Smallstep. Any questions while I swap over screen sharing?
You have one question in the chat.
Oh, so if we already have thousands of devices managed in Jamf, how does onboarding to device identity work? Do we need new hardware, or can we install in the devices we already have? So Jamf is perfect for brownfield deployments like yours, and tends to be one of our most common deployment paths, because you have the chicken and egg problem. I have my devices in MDM. How do I get Smallstep to trust them? And so that's where we set up this inventory sync. I have it set up as an API client and role. But effectively, I just set up an API client that is able to do mobile devices read and read computers. And then from there, Smallstep pulls over records of all of your existing devices. And then from there, it's just a matter of adding new devices to Jamf, and they automatically enroll to Smallstep. That answers your question. Let me click into computers here. Okay, so now let me share from my client device enrolled in Jamf. Okay. So I have a terminal up here to force my client to check in with Jamf. You can see here I'm connected to arbitrary network name. And let me try to connect to my other client here, or my other Wi-Fi network here. So tagging me choose an identity. These aren't Smallstep issued. This isn't Smallstep issued. These are from other demos I've done. So let me go ahead and try selecting these. I'm not Carl, but no, that didn't work. Let me try this one. That's a SCEP issued certificate from a different team. Nope, and it fails. So now let me go ahead and add this device to that configuration profile in Jamf. Okay, I've just added it to the scope. Let me force this to check back into Jamf. And then we'll watch it switch networks over to Indomitable Human Spirit once it pulls down this configuration from Smallstep, or well, from this configuration from Jamf. And of course, live demos, I got stuck in pending state. So you kick that off again. Forgive me, everybody. You know, this is bound to happen with a live demo. So on the Jamf side, my device is stuck in a pending state. I'm sure if I restart it here, it would pull down the new configuration. Let's see. Ah, that might help. I added the wrong profile to this device. Here we go. So now let me add the correct Wi-Fi profile to this device in the scopes. Do another recon. And here we should see the device switch Wi-Fi networks. There we go. There we go. Well, it timed out. I guess it didn't actually need to do the recon, but we can see here it swapped over to my other Wi-Fi network. Indomitable human spirit. So from a user's perspective here, they would turn on their device. It would check into Jamf just like usual, and then invisibly to the user, issue the certificate, connect to the right Wi-Fi network. And since we're doing Acme device attestation, these credentials aren't even visible to the user. So if I were to go in, try and poke around my keychain, poke around the available certificates there in the user space to connect to the network, not available because they're stored in the data protection keychain under the hood, inaccessible to the user. So it's really locked down, and you can force Jamf as an MDM to deploy these certs out and connect the devices to the relevant networks. And so that concludes my demo. Please, if there are any other questions, throw them in the chat here in the Q&A window. But that is a high-level overview of how Smallstep integrates with Jamf, and you can use it in your day-to-day flows. Summarizing real quick, we had 4 key tenets here that we're addressing: inventory, credentials, configuration, and enforcement. In our instance here, Jamf provided both the inventory and the configuration with Smallstep functioning at the credential and enforcement layer in this model. And so after a simple API configuration in Jamf, we did a device sync over from all of our devices to our Smallstep inventory. And then all we had to do was just swap the Wi-Fi payload to use an Acme-based certificate instead of a SCEP-based. And so it's an incredible tight integration. I'm personally very excited with this partnership in Jamf moving forward, and it's really quite slick how the overall solution can just push out these certificates just as we would normally, but with this crazy benefit as far as security. Let's see. What kind of feedback are you hearing from Jamf customers who want stronger certificate-based access? That's a great question. High level, I think they're looking beyond like 2025 into the biggest threats coming in moving forward. A couple of our largest enterprises are dealing with physical security threats where they don't implicitly trust the computers that are being shipped to them. And so if they can verify the TPM, they can verify the attestation key of the computer in front of them as it's enrolled in MDM, as it's onboarded to Smallstep, they have that higher level of assurance that this device actually is that device. Generally, though, and I think from a more human level, the stronger certificate-based access is great, but it also comes with a lot of user experience benefits. So these particular customers don't want to deal with phishing training as much, because if they're requiring these certificates for Wi-Fi, VPN, and single sign-on, you can phish through users all you want. You're not going to get access to these systems. So from the human perspective, I'd say that's more interesting to people. Beyond that, I'd say it's also just usability benefits. So since we're using native protocols, if you run into any potential issues, you can also just restart your device, do a new sync with Jamf, and immediately we get this implicit security benefit. So I'd say that's the general feedback we're getting back from Jamf customers.
It would be great to hear Jesse and Ryan's perspective on that as well.
Yeah.
Yeah, I was actually going to kind of add to that. I think like one of the biggest things that we hear often is, you know, kind of like what Hunter said up top, is that SCEP is problematic. And I think that the overwhelming conversation that happens around device attestation right now, honestly, for me, most of the time, and I wonder if Jesse has a similar experience, has been just explaining what device attestation actually means. And because it is such a newer concept. And I feel like, you know, people are very used to the way things used to work. And with this kind of new paradigm, it changes the conversation pretty drastically. And so it ends up leading down some very very different paths than what we're used to with like the legacy type of, strong certificate authentication, things like that. It's just a very different conversation, and that's what's been great about this partnership is we've been able to bring them in to talk about it. So yeah, it's been great.
Yeah, I think a part of it too is just making security easy and making security user friendly and maintaining the Apple experience, because device attestation is leveraging Apple native technology. We're not having to deal with really awkward, clunky workflows, and that makes your lives easier as an admin, but it also is super smooth from a user perspective because everything end to end is Apple ecosystem. And so there's it's just a really good user experience.
Cool. Yeah, thank you both. Next question: how long does it take to set up the integration between Jamf and Smallstep, and what is the lift on our team to get started? Who should be involved? Answering the first part of the question, this entire demo took me about 20 minutes last night to throw together. So that said, assuming I already have a Jamf tenant set up with the device already in it, creating a new Smallstep team, setting up the device inventory sync, and then adding the payload in Jamf took 20 minutes. From an IT resource perspective, you need somebody who has access to your MDM, so your access to Jamf, whomever has access to the Smallstep dashboard, and then whatever resources in scope, be it Wi-Fi, VPN servers, whomever is responsible for managing credentials on those servers. So generally, I think the answer is client platform engineers tend to be the people we speak to, but it can span anywhere through infrastructure.
Yeah, I for one was actually personally very impressed with how quick the setup actually is. Once it's done, it is actually really quick. It's basically some API roles and clients, go into Smallstep, add them, let it sync, and it takes really no time at all. If you set up an API connection between like Jamf Security Cloud and Jamf Pro, for example, or Jamf Protect and Jamf Pro, you know how fast those things can be. It's very much like that. It's very quick.
Awesome. And then Jesse, I think you mentioned ahead of the call, you had a couple questions.
Yeah, I'm curious. Could you explain the difference between Acme and Acme DA?
Yeah, absolutely. So the Acme protocol was written, I really need to look this up, either in the late 90s or early 2000s. I'm sure there's an exact date somewhere. As part of Let's Encrypt's ecosystem. So it stands for Automated Certificate. Oh, wow. I'm getting rusty this morning. I guess we're out of coffee in the Hawk household. But it's a protocol by Let's Encrypt. Traditionally, it's used for DNS-based validation of domains. So if you're proving to a certificate authority that you own so-and-so.com, they'd give you a text record, you'd pop it into DNS, and then as soon as it resolves for so-and-so.com, you've officially proven to the registrar that you are that entity. And so, thank you, Ryan. Automated certificate management environment. I keep trying to throw enrollment in there somewhere. So beyond that, there are a few challenge types that have existed. So DNS-01 was the one I just described. HTTP-01 is another common one. You take the string and host it on a path for a server. And then when the domain when the certificate authority could hit that endpoint, you've proven you run that server. There's additionally like a TLS-01. I might be missing others, but we added the device-attested-01 challenge type to the existing standard, which can then do this exchange cryptographically with a TPM or Secure Enclave. And so it's just really adding one additional challenge type to the overall standard that's existed for decades.
Makes sense. Thank you.
I can chime in. As the host, we had the honor of sponsoring JNUC, Jamf's user conference a couple weeks ago. One question we constantly got at the booth was, when someone hears hardware-backed device identity, they think that if they have to let go of an employee, they're stuck. Like they have the laptop, they have the physical element. So what would you say happens when someone needs to be offboarded, and that access needs to be revoked immediately,
Mhm.
and what that process is like.
Great question, because that does come up a lot. So the benefit of our offering is that the core technology is our like open source authorities. On top of that, we're layering in active revocation via CRL and OCSP responders. And so once the employee is terminated, we can just revoke the certificate on the device, remove the device from inventory in Smallstep, quarantine it from Jamf. And then from there, they lose all access to anything they could potentially use that certificate for. So it's dead, and then it kills access for the device to then issue another credential.
I'll throw another question out there. What makes Smallstep different than other folks out there in the market?
I love that, because that also comes up a lot. So the biggest objection that comes up a lot for us is what is different between the technology you're doing and everybody else? Obviously, there's the Acme component. So everything is hardware bound, key attested. We do have a couple competitors in the space, in the certificate issuance part, who can do Acme device attestation. But from my understanding, we are the only company in the world that can do it cross-platform. So it's natively supported in the Apple ecosystem. I know of a few companies that can support it there, but we have PKCS 11 connectors for TPMs on Windows, Linux, and Chrome OS, with more to follow. So we're working on an Android app. We're working for an iPhone app. Well, iOS actually works inherently if you're using Jamf. But as far as I know, nobody else can do it cross-platform. And so with our solution, you can actually have a single source of truth, pull in not just Jamf, but your other MDMs, your other unmanaged devices into Smallstep. And then from there, you have a single source of truth of all the devices you trust, beyond just a bunch of disparate device inventories. Okay. Let's see. Jesse, Ryan, I'm curious your thoughts. Have you seen any functional benefits from any customers that are ditching SCEP?
From a device attestation standpoint,
What are they asking you? Yeah.
Yeah. I mean, the biggest thing that I keep hearing right now, like obviously everybody's got something going on with device attestation. We have our own service called Network Relay that we're talking about a lot, and it uses device attestation in the background. That's kind of the idea. What we're getting a lot of is the light bulb moment with admins when you realize, oh, I can actually have this attestation happening for a service that otherwise would have required an IDP or otherwise would have required user interaction. I can have this just drop onto a device, have this device-backed authentication happen in the background. So like in the Wi-Fi scenario, that's how it always happens. But in other scenarios where you can use that in place of an IDP or in place of some additional step or authentication method, the fact that you can, like, for example, brand new Mac, dropped on the end user's front porch, they pick it up, they pull the cellophane off, they go through the setup. You're encrypting with a relay automatically based on device attestation before they ever hit a desktop. That is an incredible thing for admins and for security people, because you don't have to worry whether or not somebody's going to go and click on the VPN to enable it. That you don't have to worry about someone going through a process to make that happen. So where I get really excited about device attestation is use cases like that, where you can enable functionality with as little to no interaction completely silently on an end user computer. And then just kind of back away and let it happen, understanding that this is all going to function the way I expect it to. That's been the win for me, and I feel like a lot of organizations that we're talking to, that is the light bulb moment. That's the, oh my gosh, yes, this is incredible. I want to use it for more things, and it seems like a lot of people are getting really excited about those use cases.
Awesome, thank you, Jesse. Thank you, Ryan. Jen, unless you have anything else in the chat that I'm not seeing. I think we're good to go ahead and wrap up.
Yeah, I think you're good. Thank you,
Yeah.
Ryan and Jesse. That was great dialogue from you two.
Yeah, and thank you everybody for joining our webinar this morning. If you missed the last one, I believe it's available on Smallstep's YouTube page. You just search Smallstep on YouTube, we should be the first result. Alternatively, I think Jen has a link post pinned on our LinkedIn page as well. So if you have any questions, please don't hesitate to reach out to us here at Smallstep and Jamf. We'd be excited to talk to you about device attestation and its uses in like network relay. Okay, thank you all. Have a great week.